Wanted to go through just a little bit more strenuous example of how do you solve quadratic systems. So here we have a system. It is actually two quadratics, and we want to solve them. So the same way as we did earlier, we want to set them equal to each other. Alright, now after we set them equal to each other, we do want to move all the terms to the same side so that we can get a equal 0. So it's very important that we work to get a equal 0 going on, okay? So that's what we're looking for. When I look at my quadratic terms, I see that the one over here on the left is larger. I have 3x squared, this is just 1x squared. Remember, I want it to be positive. That makes life so much simpler. So I'm going to move everything over that direction. So I'm going to, all these things on the right are going to move over to the left. So I'm going to line them up, and I'm sure some of you can do this in your head, but just in case, we're just going to line up the movement, and so that would be a +7 right here. So all of these cancel out, which is our plan, and over here I'm going to get 2x squared, 7x, and a -3. Okay, now at that point, what I normally do is look at that and just think, okay, can I possibly factor it? And first of all, it was going to be a difficult one to factor, or it tends to be because of the 2. But I can think of no combination that's going to make that work. It's just, I'm not going to be able to subtract to 7. Nothing's coming to mind anyway, which means I actually need the quadratic formula. I can do that or complete the square, but with an a that's not 1 and a b value that's also odd, completing the square would be really, really rough. So we do need to go to the quadratic formula. So x is equal to -b plus or minus the square root b squared minus 4ac all over 2a. So you do need to put that to memory and know it. And just for the sake of discussion, let's come out here and determine what our A, B, and C values are. So we got A, B, C. I like to list them just so that we get the signs correct. So A is 2, B is 7, and C is a -3. So make sure you're bringing that negative with the 3. Okay, and as I've told my kiddos in class, these are the 2 danger zones. Be careful there. That's where most people mess up. The first one, just do the opposite sign. That's all it is. So since there's a 7 over here, that's just going to be a -7. That's all that means. And in here where you have b squared, that will always and forevermore be a positive number. Even if b is negative, if that had been a -7, -7 times -7 is still going to be a positive 49. So it's just a lot easier if you'll square it in your head and always write down your positive value. Alright, so from there, let's just show where we substituted. Our A value is 2, and our C value is a -3. Okay? So we're going to proceed. Now I always do mine the same way. We're going to start back here on the back. Okay? And if you're counting your negative signs, that kind of tells you the sign you're going to put between these 2 values. So basically 1 negative gives you a negative, 2 negatives gives you a positive, 3 negatives goes back to being negative. Okay, so it has to, every 2 gives you a positive. So I mean, if we were going to go on and we had 4, then it'd go back to being positive. But in this case, I have 2 negatives, so I know I'm going to end up with a positive sign. So I'm going to have my 49, and this is where I'm talking about, right here. That becomes positive. So 4 times 2 is 8, and 8 times 3 is 24. Okay? And then 2 times 2 is 4 down there in the bottom. All right, I'm going to keep going. And then my next step is to always put that part together. Hopefully you don't need a calculator too much. I want you to resist the urge to go to decimals. We don't need decimals here. Now that would be, let's see here, that's going to be 73. Now I don't know anything about 73. I do believe it's prime, which is great. That means we cannot reduce our radical. The beauty of that means that we're stuck, and this is our answer. So mine's a little wonky the way I drew it, but that means I'm done. Now, because this is an irrational answer, it's real. There's no i's in it, but it's irrational because of this square root of 73. I'm not going to go through and get the two ordered pairs. Okay, it can be done, but I would not require my students to go through and do that. I would ask them for the x values, but then I would let my students stop there. Okay, so that's just an idea of what it looks like when it's a little bit more